In this session, we are discussing association rules and a priori algorithm. So, association rules. Given a set of records, each of which contains some number of items from a given collection of items. And goal is that find all dependency rules on item sets of the form A determines B, where A and B are two items which are existing in the item set and where they will satisfy two conditions. What are the two conditions are there? The first condition is that they should support, that is the support of A and B must be greater than the user threshold S, and conditional probability, that is a confidence, also known as confidence of B, must be B given A must be greater than the user threshold C. So in this way the association rules will be established. So actually we are having a given set of records where each and every on some records on some sample items and from a given collection, and we are supposed to find out all the possible dependency rules. So in this example, see, we're having this set of records are there and these are the set of items. So we are having bread, coke, milk, beer, diaper. So okay, so these are the respective items we are having and these are the set of records. Record number is 1, 2, 3, 4, 5. So 5 transaction IDs are given, and against each and every transaction which are the items got sold, and that has been mentioned here. So from here we are supposed to derive this rules and this particular dependency rules, and which will satisfy two conditions. One is that is the A and B support must be greater than a threshold S, and conditional probability, also known as the confidence of B for given A, must be greater than the threshold C. Let us suppose just one example, say S, this is a support is equal to say 50%. I'm considering this one as a threshold, and C is known as the that is a confidence. Let it be also 50%. Let it be also 50%. So we know that support of X means number of transactions in which X appears by total number of transactions. So just consider here say milk. So here we are having total number of transactions is my 5, and milk has occurred for 4 different cases. So for milk the support is more than 50% because 4 by 5 is greater than your 50%. So that is the case. So 50% means here 2.5 is 50% of 5 transactions. So it is greater than 2.5. So there is a 50% of the transactions. If you consider Coke, you see Coke has occurred for 1, 2, 3 number of times. So 3 by 5 is also greater than 50% of this 5, so that is 2.5. So in both cases, if I consider only this rule, that is a milk determines Coke, you can find that both of this milk and Coke will have the support greater than 2.5. Next one is the conditional probability, also known as confidence, that is a confidence of B for given A. In that case, we know that confidence of X determines Y is support X union Y by support X. So here you can find that milk and Coke has occurred for how many times? So one time you are finding that milk and Coke, and also here also you can find milk and Coke, and here also you find the milk and Coke. So here only milk has occurred and Coke haven't occurred. So in that case milk and Coke has occurred for 3 times, out of milk has occurred for 4 times, so which is also greater than your 50% of this say this is my transaction, my 5 number of transactions, so 2.5. So you can find that this particular value is also greater than the 50%. So in this way you can easily calculate that this particular rule is having the criteria which is having the greater than the threshold support S, and this particular dependency, conditional probability or confidence, that is B given A, is greater than user threshold C. So in this way the things are getting done. So we will be going for more examples on this particular topic later on in our other calculations. Sequential pattern discovery. Sequential pattern discovery states that for a given set of objects, each object associated with its timeline of events, find rules that predict strong sequential dependencies among different events. So in this way we are going to find the rules which will predict the strong sequential dependencies among different events has occurred. So if we go for some examples, say in telecommunications alarm log, the inverter problem excessive line current and the inverter problem excessive line current and rectifier alarm determines the fire alarm. The fire alarm will ring, so depending upon these two conditions. Next one is that in point of sale transaction sequences, we can expect that the computer bookstore, in case of computer bookstore, introduction to Visual C and C++ primer determines Perl for dummies and TCL TK. So also in case of Athletic apparel store, the shoes, racket and basketball determines the sports jacket. So you can find that if in most of the transactions, if this shoes and this racket and racquetball, if both have got purchased, in that case there is a high probability that the sports jackets will be also purchased along with these purchases. So in this way we are finding the sequential pattern in our association rules. The Apriori algorithm is an inferential algorithm for mining of frequent item sets. Frequent item sets means the items which will recur into a transaction very frequently. So you are finding a pattern of these item sets. For Boolean association rules, frequent item sets means that all sets which contain the item with the least support denoted by Li for the ith item set. An a priori property is that this is my frequent item sets. So all sets which contain the item with the least support denoted by Li for the ith item set. Next one is my a priori property. Next one is my a priori property. Any subset of a frequent item set must be frequent. That means the frequency is beyond a certain threshold value given. Next one is the join operations. Next one is a join operation. To find LK, a set of candidates K item sets is generated by joining LK minus 1 with itself. So we'll be going for, that we'll be going to include more and more items and making the respective list populated with the items. So to find the LK, that is a set containing K number of items, that is a K set of candidate K item sets is generated by joining LK minus 1 with itself. So that item will be included in LK minus 1 to generate the item set LK. Uses a bottom-up approach where frequent data sets are extended one item at a time, and there is a candidate generation and groups of candidates are tested against the data. So it is known as bottom-up approach because in this case at first we will be considering the set containing a single item, then we'll be adding another item into the sets, so we'll be containing sets containing of two items. So in this way the respective set will be growing. So it is known as the bottom-up approach where frequent data sets are extended one item at a time. That is a candidate generation, also known as this process, and groups of candidates are tested against the data. The next property is that the design to operate on databases containing transactions, as example collection of items brought by customers or details of website frequentation. So you can find that in case of say sales data set, we are having multiple different transactions and which items have got purchased against those transactions. So after going for the details research and analysis, we shall be finding out the collection of items brought by the customers very frequently or details of the website frequentation. Now here we are discussing the what is a support. So the first property we are discussing, that is a support. What is a support here? So support is a support of an item set X. We also write it as SUPPX is the proportion of the transactions in the database in which the item X appears, and that signifies the popularity of an item set in the set of transactions. So support X is equal to number of transactions in which X appears. That means in the previous example, how many times a milk has appeared in multiple different transactions and total number of transactions. So if you consider the item say milk, so we know that milk appeared for 4 number of times out of 5 different transactions. So this ratio will be known as the support. That is my 80%. That is my 80%. So if we have the support threshold of say 50%, then obviously the milk will be coming into our consideration because 50% is lesser than 80% or 80% is greater than 50%. So this particular item X is having more support compared to the threshold support. Next one is my confidence. Next point is my confidence. So what is the confidence? Confidence signifies the likelihood of item Y being purchased when item X is purchased. So that means support of X union Y by support of X. So this ratio is known as confidence x, when x then y. So now if x then y. So in that case, you know that how many times x and y simultaneously have occurred in the transaction. So how many times, and by the support of x. So how many times milk has got purchased along with the bread, say. So in that ratio will be support of milk union bread by support of milk. So that is my confidence level. Then obviously the user will give some confidence level threshold value, and depending on that we will be considering those item sets or those rules which will be crossing the confidence level or more than the confidence level given. Next property is known as the lift. Next property is known as the lift. Signifies the likelihood of the item set y being purchased when the item x is purchased while taking into account the popularity of y. So that is my lift x determines y. So support x union y by support x into support y. So support x union y. So how many times x and y have occurred in the same transactions by support x, that means how many times what is the support for the x and how many times support for the y. And what is this support x union y? We know that here we have defined that is a number of transactions in which x and y appears by total number of transactions, that will be the support x union y. And support x means the same thing, number of transactions in which x appears by number of transactions, and support y means number of transactions in which y appears by total number of transactions. So in this way we'll be calculating the lift. The fourth property, that is known as conviction. So conviction x determines y is equal to 1 minus support y by 1 minus confidence x determines y. So the confidence we have defined here. So from here we'll be getting the right hand side, support y, support x, everything we have defined here. So from here you can easily get that how to calculate the conviction x determines y. So this x determines y is nothing but one of the association rules. Next, a priori algorithm steps. Apply minimum support to find all the frequent sets with k items in a database. So use the self-join rule to find the frequent sets with k plus 1 items with the help of frequent k item sets. So in the previous discussion also we have told that we will be having the k item sets, that means the item sets containing k number of items, and in that case we'll be adding another promising item within that, and we'll be making that one k plus 1 item sets. So repeat this process from k is equal to 1 to the point when we are unable to apply the self join rule. So until this self join rule is getting false, whenever that's until or say till the self join rule is applicable, we shall go on adding new items to the previous item sets. So this approach of extending a frequent item set one at a time is called the bottom up approach. So it is known as bottom up approach because we are starting with the one item set and then we'll be reaching to the last k item sets. After that the self join rule will not be valid. So let me go for one flow chart. So see here. So we are having the set of items also known as item sets. Generate k item set candidates self join steps. So there is a candidates join steps here, and then check support, that means the support threshold is given. So those item sets which will not be supporting this support value or not greater than the support value given, so they will be pruned, so they'll be checked out, they'll be what should I say, they'll be discarded, and will be remaining with the those item sets which will be crossing the support threshold. And then we are getting this frequent item sets, and a set of k minus 1 frequent item set is phi. If it is not, then we shall go on repeating this process again and again, and when this set of k minus 1 frequent item set will become phi, then we shall go for the stop. So in this way you can find that how this a priori algorithm will be applied, so that we have described in the form of a flow chart for your better understanding. So in the next videos we'll be going for the more detailed analysis, we'll be going for one example, we'll be going for the respective Python code for your understanding. Thanks for watching this video.